So I should go there. You receive this data, okay? After receiving this data, what is happening? This point just giving the information to the neighboring point. This is giving information to the neighbor point. So after getting the information, the tensor gets more information. And when it gets more information, you can find out what is the value of lambda, what is the value of lambda 2 in a tensor. And when you will get lambda 1, lambda 2, you can check if lambda 1 and lambda 2 are same, it means it will remain a disk. But if lambda 1 and lambda 2 are slightly different, then what will happen? They will get a little bit orientation. Can you check this thing? In the first figure, after first voting, this remains still a disk. But after some time, after more voting, they get a little bit of orientation. And after orientation, this becomes converted into what it should call a bar. Okay? And this bar, with the orientation, if you will try to join them, you will get a extracted curve. So this is the basic idea. I'm not talking that this is the exactly, but this is the basic idea, so that you can know, okay, when tensor voting will be there, tensor get more information with lambda 1 and lambda 2, and with this direction, you will find out the orientation. And when you get the orientation, you can check, okay, because this is oriented this side, so curve should go this side. So you will find a line. Yes.
Questions. Are or were tensors used in any way to do some object detection? Because if you can find like curves and straight lines and stuff like that, then you can combine all that information to find some objects with distinct curves and stuff like that. So
let me show you the slide.
Oh, okay. Sorry, if I'm jumping, then
no problem.
Like no,
because the thing is that
if
once
we're getting to that point, it's okay.
Once the broad idea is clear, then if I will go into deep, you will, oh, this is the tensor voting. How we will do the integration? Because if I'll explain integration, there is no use of that. But if I'll explain the basic idea, what I'm doing here, this is a result in 2D. Junction input, and when tensor voting takes place, the output is like this in the second figure. Similarly, a reason input in C, you are getting some map here. And if you see this figure, the input data is noisy. I'm sorry. Now this is a complete figure. Okay? Here is curve, survey is curve, this is junction. So when you are getting input from each point, which is known as token. So input is token. From token you are building up your tensor by communicating the information from one point to another point. This will cover this region. This will cover this region. So they are getting information from one point to another point. And slowly they start building up the orientation, that where the curve should be tilted. Okay? And so this one, this figure you are getting out. Look, here you are getting a big spots. It means you are getting this here. It means lambda 1 and lambda 2 are nearly same here. That's why they are getting a bigger spot. And the noise is removed. Important thing is that from when you abstract the image, the noise is removed. So from the noisy data, you receive it without noise. I think you got the answer?
Yeah. Well, I guess that's for like some symbols like that, but do they do like more?
There were a lot of data I couldn't put it into my slides.
Okay, but have you seen some papers on like object detection using tensors? Okay.
It's not object detection basically. I didn't do it with
object representation.
Exactly. It was image extraction. That was the important point I saw everywhere. Okay, let us start about the voting. How the voting is done. Let me discuss some points here. Token input. Okay, the token is encoded in form of a tensor. Okay, when you receive tensor, it will distribute. This is the step I'm going to explain. After tensor voting, the tensor gets more information, so it becomes refined. Again tensor voting, it will become saliency tensor field. It will be converted into field. I will show you what is field. And after field, you will decompose and you will find whether it's a surface or curve or junction and feature extraction. Okay, so this is the whole algorithm. So we are in this stage. Let me show you the figure. Suppose O is a point where there is a tensor. Okay, although I have shown these points very far away, but the fact is that the region is very close. Okay, originally the tensor which is sending information, it is not sending to some 1 meter or 2 meter. It's sending its information to very near points. Say we have a tensor which is in this format, because the basic things, as I told you, is either bar shape or disc shape in 2-dimensional. Okay. Now from O, we want to send the information at point P. Okay. So this is the voter and this is the receiver. This is going to vote and this is going to receive. Okay. And this is the curve. This length is say S. This length is L. And from tangent, this angle is theta. Okay. What will happen? This bar, when reach here, it will change a little bit of its orientation. It will attenuate it. It will reduce its value. So, suppose this value is x here. It will not x here.
It will not
be the same. If it is x, magnitude x, it will not be x here. It will be reduced. Otherwise, this information can reach anywhere. So, at how much distance it will go?
Why is it reduced again? Why is it reduced again? Please.
When you send the information from one point to another point, it will reduce. You can say the effect of this point will not go very large distance.
Okay, but why? Like why is it reduced?
Let me show you. It's called decay function. It will decay.
Okay.
Because the feature at one point is not going to impact the feature at very far point. It will have an impact on the close by points.
Okay.
Okay, that's the reason. So what we have to do, if we have this value, we have to find out the value here. This is the basic voting. Okay. So once we will get this one, so now the question is, up to which point this can have an impact? The tensor which is here, the information which is here, up to what distance it has the impact, that impact is up to 45 degrees. Because if P point will go far, this angle will increase. And when this angle becomes 45 degree, they will say, okay, not more away from this point. So it will reach to a point where the angle is 45. If we go further this point, the impact of this will not go that side. This is the criteria taken by the who suggested this whole thing.
So for different column, the angle are the same.
Look, he has started doing all the calculation with some standard things, and for that standard he has taken at 45 degree. And I didn't see the real calculation what he is actually taking.
Excuse me, what is the shape of S? Shape of S is the part of the symbol.
Yeah, actually